nice.
Okay.
When I turned you, I was like, what? I wrote about the wrong thing. Like, I wrote about how he was like saying that we should ban plastic bags before I started realizing that was wrong. How much you get a paragraph.
All right, here we go. We are talking about law of science and law of cosine. You guys have a test coming up soon here. Yeah. Yeah, it might be moved. I didn't know about the whole short class things on Friday, so might be pushed to Monday. Either way, you'll have a reading. Today we're talking about law of science. Now, you should have had law of science in geometry, but we have to add a new little thing to law of science in this class. And so, previously, you have learned how to use solve a right triangle. And back in geometry, we did this using law of science to solve, find sides and angles of oblique triangle. So oblique triangle means it's a non-right triangle. Trig works with right triangles, but it turns out it's actually really easy to do some math. And I was going to derive it, but I'm not going to. We were going to derive it. It's actually really, really easy to derive. But it turns out it's really, really easy to do some math, and we can use trig on non-right triangles also. And so, law of science is very simple. First of all, we have a triangle set up here. It is absolutely important that you understand how we name triangles, really any polygon. We use capital letters for each vertex, and the side opposite the angle gets a lowercase of that same letter, okay? So little a is the side length opposite the vertex A, okay? Little b is the side opposite capital B, okay? And that's really important. Now, it turns out law of sines is very simple. It says, if you want, you can take the sine of your angle A and put that over its opposite side. It would be equal to the sine of angle B over its opposite side length, which also happens to be equal to the sine of angle C over its opposite side length. Now, obviously, we don't use 3. We're going to take any 2 pieces of information that we have, and basically, we can set up a proportion and solve, okay? So, if we're given triangles, given very particular information here, this is important. On this one, on number 1, what I notice I have this, I have my angle here of 104, and I want to figure out information about its opposite side. I also have this angle of 47, and they gave me information about its opposite side. When I look at this information, they have given me angle, side info. When I look around this triangle, traveling around this triangle, I'm approached with angle, and side. So they've given me angle, side information. That means I can use law of sines really easily. So we're going to set up a nice little proportion. So I'm going to set up the sine of my 104-degree angle over my x side, which I'm trying to figure out. And that's equal to the sine of 47 degrees over 15. So we get to write our proportion. And what mode should we be in on our calculators? Got to be in degree mode first of all. And then we can cross multiply to solve here. So I'm going to multiply x times the sine of 47 And that's going to be equal to 15 times the sine of 104. So I like to just write it like that. And then how do you get x by itself? Divide by sine of 47 on both sides. So sine of 47 goes away. And in my calculator, I very easily get to put in here 15, I'm in degree mode first of all, times the sine of 104 divided by the sine of 47. It's really important that you close your parentheses just so there's no confusion there. Learning how to use your calculator is a big part of using 105. Okay. Round to the nearest tenth, 19.9 units, centimeters it looks like, with what that is. Okay, that was fantastic. Let's see, number 2 here. On number 2, I have an angle measure here, and I'm trying to figure out the opposite side, so that's okay. Then I have an angle, but I don't have something on that opposite side. Oh, and then I have this 28. Okay. Well, let's see. This triangle, the information that they gave me was, they gave me an angle, and then they gave me a side length, and then they give me an angle. So this is angle, side angle information here. But I don't have another angle side pair. So, Will, what did you say? Yeah, I can figure out my missing angle right here because I have that side, so I need that opposite angle. So we can do 180 minus 63 minus 42, and that gives me 75. So this angle is 75 degrees. So you might need to find the missing angle. You know that a triangle has 180 degrees. And now that I know that it's 75, now I can set up my side and opposite angle info. So I'm going to write the sine of 42 degrees over my x length is equal to sine of 75 degrees over 28. All right, go ahead and solve that. What'd you get? Is that right? Mm-hmm. Cross multiply. Make sure you're all getting the calculator work correct. Okay, what'd you get? 19.4. All right, did you ever get that 19.4? Mm-hmm. Yeah? Okay, I hope so. Okay, so given that information, pretty easy to figure out what those side lengths are. But it becomes a little bit different when we have to find angles. Now in geometry, we got to ignore this. But in pre-cal, we don't get to ignore it because we have to know all the little parts. So when we're trying to find missing angles, it's called the ambiguous case here. There are lots of possibilities. And I don't like to discuss all of this stuff, but you want to pay attention to when you're given the SSA information. Now you can reverse that, and it spells a bad word, right? Okay. So you need to look out for when you get that bad word info. Okay. It's a pain in the, all right, which means you got to pay more attention. All right. Okay. So whenever you're given this information, we have to be very careful. And I like to call this the swinging leg triangle. And so let's see. I don't want to figure all this stuff out, but you're going to see a lot of different cases here. So I'm going to draw the triangle, and I need you to write all this stuff down because it's really, really important. Okay, so what can happen here is that we could have one triangle, there could be two triangles, or there could be no triangles. That's what the ambiguous case means, that we could have one, we could have two triangles, or we could have no triangles. All right, and it has to do with a lot of different things that you don't quite know everything about yet, but we will a little bit later. Okay, so we have information given below. We have information here about triangle ABC. I have one angle that I know, so I'm going to go ahead and draw this triangle like this. I'm going to call this angle A. Angle A is what I know. It is 60 degrees, so I'm going to put that angle right there. And then they tell me, here's B. Side AB is 30 inches. So here's my 30 inches right there. And then here's must be angle C. BC is 27. So BC is 27 inches. And it's asking us to find the measure of angle C. So this is the question. We're trying to figure out the measure of angle C. Now, what you'll notice about the information given in this picture, they've given us an angle and a side and a side. And again, this is the no-no information. So what we have here is, you can look at my little arm, right? This is a fixed length. And this is a fixed length. Side BC is a fixed length. But this angle at the top, I don't know what that is, okay? So it could be nice and wide like I have it drawn, but it could also swing in like this and create another tiny triangle, all right? So what can happen is this leg right here can swing in and create a potential other little triangle. Do you see that? Can you imagine that swinging in so we get this other angle C right here? So that is what I call that the sort of swinging leg problem. I don't know what that angle is. It could change, creating two possible triangles. This big blue triangle and this sort of really weird triangle here, okay? So they're very closely related. We're going to figure this out. So first I want to start with what I can figure out. Right off the bat here, I have my 60-degree angle, and I do have information about this opposite side of 27. So I can set up a little sine info here. So sine of 60 degrees over 27 is going to be equal to, now I'm trying to figure out angle C, and I don't know what that is, but I do have the opposite side info of 30. So I'm going to do sine of C over 30. So we're actually going to figure out what C is. Let's see, I'm going to cross multiply here. So I get 27 times the sine of angle C is equal to 30 times the sine of 60.
Since you're cold air. No, they're not doing it.
All right. How do I isolate the sine of C? Divide by 27. Good. So we're going to divide by 27. So I get the sine of angle C is all of that jazz. I'm just going to write down 30 times the sine of 60 degrees over 27. Now, how inverse sine? Yeah. So if I want to free the C right now, I have to do the inverse operation to cancel out the sine. We did that before. So we have to do the sine inverse of both sides so that the sine and sine inverse cancel. And so in my calculator, I'm doing, let's see, sine inverse of 30 sine of 60 degrees divided by 27. So again, making sure you use your calculator correctly. This can be quite involved. All right, we get C is 74.2 degrees. Okay, so what that means is this angle could be 74.2 degrees. And then the option here is if this leg swung in, it maintains its same length. It's still 27. And here what I have is an isosceles triangle. That's 27, and that's also 27. The base angles also have to match. This is 74.2 as well. What? Isosceles triangles, if the sides match, what do we know about the angles? They match as well. No. All right. So because this triangle is isosceles, those legs are both 27. That swinging leg thing. All right. These angles have to match. They're both 74.2. I need to figure out the other side of angle C. How do we figure out the other side of angle C? Yeah, so 180. So I'm going to call this C2. Could be 180 minus 74.2. Which is, let's see, 180 minus 74.2, 105. Oh my goodness. Yeah. So, and does that triangle make sense? Would this be a possible triangle with 60 degrees, 105, and something else?
Yep.
It could still be, yeah? Okay. And so that is, there are two triangles in this case. So the measure of angle C has two options. C could be 74.2 or 105.8 degrees. The nice thing is you don't have to solve both triangles. You just have to figure out if there's two possibilities here. Okay.
What if it wasn't? Like, how would you know if there wasn't?
Well, so the math works out favorably. Like, we're going to do another one here. We'll see a lot more where it won't make any sense. Let's look at this one, number 8. Okay. Number 8 is interesting. It's asking us to find the measure of angle B. Well, yeah, well, I don't know that I would, though. Okay. All right. Again, they're telling me that I know angle C, so just so that this goes well, I get used to drawing it a certain way. This is 102 degrees. Does it look like a 102 degree angle?
Sure.
Doesn't, but that's okay. All right. Let's see. We're trying to find angle B. So again, I'm going to make that this angle that always, the one I'm trying to figure out, I want over here, which means A is at the top. Okay, so I'm always going to set up my triangle the same way, just so that my picture, I can follow my own picture here. All right, so AC is 21 and AB is 24. And again, they're giving me that crazy angle side info that creates a big problem for me. Okay, two potential triangles. So to start, I have enough information to get things set up. I have opposite angles inside, so I'm going to go ahead. The sine of 102 over 24 is equal to sine of B over 21. Cross multiply. All right, so that is, let's see, I'm going to do 24 times the sine of B is equal to 21 times the sine of 102. I'm going to divide by 24. And then how do you get B by itself? inverse function. So we're going to do sine inverse of both sides. So I get b equals sine inverse of 21, sine of 102. And again, make sure you're in degree mode. All divided by 24. So I get 58.9 degrees. We round to the 10th place. Okay. So potentially B could be 58.9 degrees. But again, it's that swinging leg thing. So what can this leg do? It can swing in and create this secondary triangle that happens to be isosceles. So there's another 58.9 right there. I need the other side of that angle, which would be what? 180 minus 58.9 equals 121.1. Okay. 121.1 degrees. Now, is that possible?
No.
Why not?
Because they have.
Yeah, because 102 and 121, that's way over 180 degrees. So that angle can't exist. Okay? Does that make sense to you? Why that's an impossibility? Okay. So this is only one triangle. And angle B is 58.9 degrees. Okay? And so that one is too big, because our little 102 and the 121 and that little tiny angle is over 180. All right. Okay, so that can happen. And then let's try one more here. Another possibility. Right here, let's look at number 7. This one's real interesting. You guys don't have the background yet to understand why this works. Or doesn't work. Let's see. Angle C, so again, I'm going to set up my triangle in the exact same manner here. Angle C is what I know. I'm going to put that right there. Angle B is what I'm trying to figure out. So that's my angle over here, which means A must be on top. Let's see. AC is 34 and AB is 26. Okay, so what's my initial setup here?
Sine of 89 over 26
Mhm.
equal sine of 8 over 34.
Okay. All right, we can cross multiply. Let's see, so 26 sine of B equals 34 sine of 89 by cross multiplying. And then I need to divide by 26. Yeah. And then I have to do sine inverse. Sine inverse. Now, this is kind of interesting. It says error. Yeah, this is really interesting. On our unit circle, I don't know if you've noticed this, but on our unit circle, which I happen to have on the board right here, sine is always the y coordinate, and the tallest value sine can be is 1. Okay? The lowest sine can be is -1. All right? That is the longest length of that leg in the triangle. So here in this fraction, we have 34 over 26. Is that more than 1 or less than 1? More than 1. We cannot have an angle that has a ratio bigger than 1. So this is always going to be an error. But you can see when you plug it in, the math, it just doesn't math. And that's kind of the nice thing here. It's a domain error. This is bigger than 1. It's too big. So this is not possible. There are no triangles. No triangle doesn't exist. Yep. And so that will come up. You get lots of different options here on Delta Math. 3 different ways that can happen. So their first set of questions is just like this. Very easy setup. The second set is this, where there's just one triangle. And the third set's going to be a mix of these two. Okay? Do you have questions for me?
No.
Okay. It is Delta Math. It would be blaring loud. Yeah.